Hello students, this is Varun. In the chapter set theory, next we are going to start with type of sets. Well, first type is empty set. A set which doesn't contain any element is called empty set. Sometimes it is also called void set and sometimes it is known as null set. Again, the set which doesn't contain any element is called empty or void or null set, and usually it is represented by the sign psi or sometimes just a set of curly brackets without any element. These two signs represents empty sets. For example, set of negative whole numbers and set of even prime numbers greater than 2, both of these sets are empty sets. The reason behind this is we know that whole numbers starts from 0. Whole numbers are 0, 1, 2, 3 and so on. There is no whole number which is negative. Means negative whole number doesn't exist. In the same way, even prime number is only 2. There is no even prime number greater than 2. Since there is no negative whole number and there is no even prime number greater than 2, that's why this set will have no element. Even this set will also have no element. Since these two sets do not contain any element, so these are empty sets. Next, we have the singleton set. A set which contains only one element is what we call singleton set. Well students, you need to understand that singleton set contains only one element. For example, set of whole numbers which are not natural. We know that 0 is the only whole number which is not natural. So this set will contain only one element, that is 0. So this is the example of singleton set. And this example of set of whole numbers which are not natural can be represented as set A equals to, in curly bracket, only 0, because this set contains only one element. Now next we have finite set. A set that contains a limited or definite number of different elements is called a finite set. Well students, finite set is that set which contains a particular number of elements, means which contains a definite number of different elements. For example, a set of vowels of English alphabets. We know that there are only 5 vowels and that set will contain the elements A, E, I, O and U. Since the set of vowels in English alphabets contain only 5 elements, means it contains limited or definite number of different elements. So this is the example of finite set. Let us take one more example for finite sets. Let S is the set such that X is month of year. We know that in a year 12 months are there. Number of months in a year are 12, which is finite or which is definite. Since number of months in a year are limited, that's why this is also an example of finite set. We may have some more examples of finite set, like prime numbers less than 20. We know that again we have limited number of prime numbers less than 20, so that is also an example of finite set. Well students, next we have the cardinal number or order of a finite set. Well, the number of different elements in a finite set is called the cardinal number or order of that set, and it is denoted by, if set is A, then its cardinal number is denoted by n of A, or sometimes it is also denoted as O of A, means order of A. Like this set A, finite set A has only 5 elements, 1, 2, 3, 4, 5. So its order will be 5. or its cardinal number will be 5. In the same way, cardinal number of set S is, since X is the month of year and we know that a year has 12 months, so cardinal number of set S is 12. Mind one thing more, the cardinal number of the empty set is 0 and the cardinal number of a singleton set is 1, and the cardinal number of an infinite set is never defined. Now what are infinite sets? Let us discuss. Well students, next we have infinite set. As name suggests, infinite set is that which is not finite, means a set whose elements cannot be listed by the natural numbers, or the set which contains an unlimited number of different elements is what we call an infinite set. For example, the set of even natural numbers. We know that even natural numbers are 2, 4, 6, 8, 10, 12 and so on. They are infinite in number, means they are not limited, they are unlimited in number. That's why set of even natural numbers is example of infinite set. In the same way, set of all the lines in a plane. We know that in a plane infinite lines can lie. Similarly, set of all the points on a line, that is also an example of infinite set, because a line is a collection of infinite number of collinear points. Since number of elements of infinite set is unlimited, means number of elements in infinite set is not defined, that's why the cardinal number or order of an infinite set is never defined. Next we have the equivalent sets. While students, two sets A and B are said to be equivalent sets if they have same order, or we may say if they have same cardinal number. Means two finite sets A and B are said to be equivalent if they have same number of different elements. That is why two sets A and B are equivalent if number of elements in A is equal to number of elements in B. It can also be stated as the cardinal number of set A is equals to cardinal number of set B, or order of set A is equals to order of set B. For example, if we have set A with the elements 1, 2, 7, 9, 10, as we can see that order of set A is 5. In the same way, we have set B with the elements A, E, I, O, U, and the cardinal number of set B is also 5. Since both set A and set B have order 5, means the cardinal number of set A is 5 and that of set B is also 5. That's why A and B are equivalent sets. Well, two sets A and B are said to be equal if every element of set A is a member of B and every member of set B is element of set A. For example, let there be set A with the elements 1, 7, 9 and 8 and set B has the elements 9, 8, 7 and 1. Since all the elements of set A are in B, like 1 is there, 7 is there, 9 is there and 8 is there. In the same way, all the elements of set B are in A, like 9 is there, 8 is there, 7 is there, 1 is there. So we have seen that all the elements of set A are in B and all the elements of set B are in A. That's why set A is said to be equals to set B. So in this video, we have discussed about empty set, singleton set, finite set, infinite set, then after cardinal number or order of finite set, then after we did equivalent sets, and finally we did equal sets. Further we will do in our coming videos. Thank you.